300,000 years ago, the middle of the Ice Age. Earth was not a human world. It belonged to predators. The planet's climate was colder, harsher, and far less forgiving than it is today. Vast glaciers advanced and retreated across continents. Forests thinned, grasslands stretched for hundreds of kilometers, and in these open spaces, apex predators dominated the land. The cave lion, Panthera spelaea, was larger and stronger than any living lion today. Males could reach up to 3.5 meters in length and weigh over 300 kilograms. Fossil evidence suggests they hunted in coordinated groups. The cave bear, Ursus spelaeus, was a walking fortress. Some males exceeded 1,000 kilograms. Their skulls show immense jaw pressure, enough to crush bone. These animals hibernated in caves, sometimes the same caves early humans used for shelter. The dire wolf, Canis dirus, was bulkier than modern wolves. Its bite was built to tear through thick hides. Fossil sites in North America and Eurasia show signs of pack hunting behavior. Humans were not the only social species. Then came the saber-toothed cats, Smilodon, with curved fangs capable of puncturing the thick hides of giant prey. The lynxes, mega-eagles, crocodiles, pythons, and other silent predators filled the ecological web. Each posed a different kind of threat. Some were ambush predators, waiting at water holes or tree lines. Others pursued their prey across open ground. Still others attacked from above, like Haast's eagle in the southern hemisphere, capable of lifting a human child. The air smelled of danger. Every sound could mean death. In this world, early humans did not dominate. They survived. Homo erectus had fire and basic tools. Homo heidelbergensis showed signs of cooperative hunting. And Homo sapiens, who had just emerged, was still far from dominant. They were slow. Their nails were blunt, their teeth made for chewing, not tearing. Their skin was thin. No fur, no claws, no venom, no armor. They were not apex predators. They were prey. Their primary defenses were not physical, but behavioral. Avoidance, vigilance, group living, staying close to fire, choosing the right terrain. Archaeological evidence shows that early hominins avoided predator-rich zones. Fossil sites are often located on cliffs, near rivers, or in elevated regions, places where large predators were less likely to attack or corner prey. Humans did not evolve as hunters. They became hunters by necessity. But long before that transformation, they were hunted. This is where the story begins, not with conquest, but with fear. Not with power, but with vulnerability. To understand how humans became dominant, we must first understand how they survived as prey for tens of thousands of years. This is the forgotten chapter in our evolutionary history, not the rise of man, but the survival of the hunted. Part 2. Instinct to escape, the first survival strategy. Before humans became predators, they survived by evading them. The earliest members of our genus, Homo erectus, Homo heidelbergensis, and eventually Homo sapiens, faced an ecosystem filled with predators. Their initial response to danger was not confrontation, but avoidance. They slept in trees when possible, like their primate ancestors. This limited attacks from ground-based carnivores during the night. When they descended, they carried burning branches, not to cook, but to defend. Fire was not just a tool, it was a shield. Many predators fear open flames, and early humans learned this quickly. Part 2. Instinct to escape, the first survival strategy. Before humans became predators, they survived by evading them. The earliest members of our genus, Homo erectus, Homo heidelbergensis, and eventually Homo sapiens, faced an ecosystem filled with predators. Their initial response to danger was not confrontation, but avoidance. They slept in trees when possible, like their primate ancestors. This limited attacks from ground-based carnivores during the night. When they descended, they carried burning branches, not to cook, but to defend. Fire was not just a tool, it was a shield. Many predators fear open flames, and early humans learned this quickly. Habitat selection became a survival factor. Archaeological evidence shows that early humans favored cliffsides, riverbanks, and high ground. These areas were more defensible. Caves were sought after, but only after ensuring no bears or lions had already claimed them. Sometimes, bones in the same site reveal both human and predator remains, evidence of shared or contested shelters. Movement patterns shifted towards safety. Small bands of individuals, ranging from 10 to 30, traveled together. There was no single leader, but every member had to stay alert. One mistake could cost the group. Spatial memory began to evolve. The brain retained details of landscapes, locations of safe water sources, high perches, escape routes. Landmarks became mental maps. The human hippocampus, a brain structure involved in spatial navigation, likely developed greater complexity during this period. Knowing where to run was just as important as knowing when. Survival required continuous scanning, noticing broken branches, fresh tracks, disturbed ground, the smell of blood or rot, the sound of snapping twigs or rustling brush. These were early signals of danger, and missing them meant death. Vision adapted accordingly. Human eyes evolved to function well in dim light, dawn, dusk, and the shaded undergrowth of forests. The retina became sensitive to motion. Detecting a silhouette between trees or movement on the horizon became a vital skill. More importantly, the brain began to treat these stimuli with urgency. A distant roar triggered a full-body response. Heart rate increased, muscles tensed, attention narrowed. This reaction, mediated by the amygdala and hypothalamus, formed the basis of the fight or flight response. But for early humans, fighting was rarely an option. Flight was the default. Fear, far from being a weakness, became a survival tool. It prioritized safety. It conditioned caution. It taught the brain to recognize patterns of threat and retain them for the future. Those who learned fastest lived longest. This led to an early form of pattern recognition. Individuals who connected certain clues, like a foul smell and the appearance of hyenas, were more likely to avoid ambush. The brain began to link separate observations into coherent warning systems. Over time, this constant vigilance shaped social behavior. Groups evolved shared alertness. One person's discovery of a predator trail became knowledge for all. Warning calls, gestures, and glances became early forms of communication. Cooperation was not driven by empathy, but by necessity. Fear drove innovation. A branch held near a fire became a crude torch. Stones arranged near sleeping areas acted as primitive deterrents. Barriers of thorn bushes protected vulnerable zones. Offensive behavior preceded offensive capability. Even tool use reflected this survival mode. The earliest stone flakes were not made to kill, but to cut meat quickly and leave the site before scavengers arrived. The goal was not confrontation, it was speed and efficiency. The body also adapted. Bipedalism allowed humans to see farther and react faster. Standing upright gave a vantage point, detecting predators before they closed in. The upright posture also freed the hands for carrying children, tools, or weapons if necessary. Auditory memory sharpened. The rustle of dry grass, the tone of a bird's alarm call. These subtle cues became part of an evolving mental catalog. The brain transformed into a biological radar. Even today, modern humans retain these features. We startle at sudden noises. We scan dark rooms. We instinctively feel unsafe when alone in unfamiliar environments. These behaviors are not cultural. They are neurological. They are inherited. The instinct to escape was not just a phase. It was a foundational stage in human evolution. It selected for intelligence, memory, collaboration, and vigilance. Before humans fought back, they survived by watching, learning, and running, and that long-running strategy laid the groundwork for everything that followed. Art 3. Fear. hardwired into the human brain. The evolution of fear was not an accident. It was a neurological necessity. As early humans navigated a world filled with predators, a key part of their brain underwent significant adaptation: the amygdala. Located deep within the temporal lobe, this almond-shaped structure became the central processor for fear. The amygdala detects threats and triggers immediate survival responses. It does not reason, it reacts. For early hominins, this reactivity was life-saving. A delayed reaction to danger often meant death. Fear was not a sign of weakness, it was a survival mechanism. Running from a predator was not cowardice, it was an information-gathering strategy. While fleeing, humans learned how predators moved, where they attacked, and how to avoid them in the future. Flight was paired with observation. Observation fueled memory. Memory shaped intelligence. Over time, repeated exposure to danger created conditioned responses. A snapping branch, a shadow at dusk, a sudden silence in the forest. These signals were encoded into the nervous system through repeated experiences. Startled responses became reflexive. They no longer required conscious thought. This pattern of repetitive threat recognition resulted in evolutionary learning. The brain began to build internal models, predictions based on memory and pattern matching. These predictive systems laid the foundation for what we now call anticipatory cognition, the ability to forecast threats before they fully emerge. This capacity to simulate danger scenarios based on previous experience is not exclusive to humans. But in humans, it became far more elaborate. It contributed directly to the development of complex planning, group coordination, and eventually, strategic hunting. Those who responded too slowly were removed from the gene pool. Those who overreacted to harmless stimuli wasted energy. But those who recognized real threats at the right time survived and reproduced. Thus, fear became genetically selected. Modern genetics and behavioral neuroscience support this. Variants of genes related to dopamine regulation, stress hormones, and neuroplasticity, such as COMT, BDNF, and FKBP5, show patterns linked to threat sensitivity and memory formation. In effect, those who mastered fear passed on that mastery, not just culturally, but biologically. These inherited tendencies form what some researchers refer to as ancestral PTSD. Post-traumatic stress disorder is often seen as a modern condition, but many of its neural pathways are ancient. The hypervigilance, the startle reflex, the recurring intrusive memories, all of these had adaptive value in prehistory. They helped individuals remain alert in dangerous environments. Today, those same pathways still exist. Many humans experience anxiety in the dark, discomfort when being watched, or unease in unfamiliar territory. These are not flaws in the system. They are remnants of a time when such instincts saved lives. The amygdala is still active. The hypothalamic pituitary adrenal, HPA, axis still prepares the body for threat. Cortisol and adrenaline still flood the bloodstream during perceived danger. Pupils dilate, muscles tense, breathing accelerates. These responses occur whether the threat is a predator or a shadow. And they are not unique to individuals. They are shared across cultures and populations. Studies on infants and toddlers show innate fear of falling, loud noises, and looming shapes, long before cultural learning can take place. Fear is not just learned, it is inherited. This inheritance, while rooted in survival, also laid the groundwork for more advanced cognition. The ability to imagine danger without experiencing it. The ability to teach others what to avoid. The capacity for storytelling, warning, and myth-making all emerged from the same neural circuits designed to process fear. In this way, fear shaped not only survival, but culture. Our capacity to anticipate risk gave rise to cautionary tales, moral codes, and defensive strategies. Entire rituals were built around avoiding danger. Rituals involving fire, animal bones, cave markings, and symbolic gestures. These behaviors emerged as extensions of the same neural system that made early humans run at the sound of a snapping twig. In short, the human brain did not evolve in spite of fear. It evolved because of it. Understanding this reality reframes our place in the natural world. Intelligence did not begin with abstract thought. It began with concrete danger. Before we invented tools, art, or language, we responded to threats. And in doing so, we rewired our own brains for the future. Part 4. The shift from prey to strategist. The transition from hunted to hunter did not happen instantly. It was a gradual shift driven by necessity, cognition, and group adaptation. At the center of this transformation was a species often overlooked in the human lineage, Homo heidelbergensis. Living between 600,000 and 200,000 years ago, Homo heidelbergensis showed the first consistent evidence of large game hunting. Unlike earlier hominins who scavenged or hunted small animals, these humans pursued elephants, wild horses, rhinoceroses, and other megafauna. They were no longer merely reacting to danger, they were calculating it. The tools remained simple but effective. Wooden spears, sharpened stone tips, hand axes made from flint and quartzite. These were not projectile weapons. They required close-range strikes. Hunting at that range meant high risk, but also a shift in mentality. Instead of fleeing, humans began waiting. This marked a major behavioral reversal, adopting the tactics of their former predators. They learned to track movement, analyzing footprints, broken branches, and scat. They studied wind direction to avoid being detected. They moved quietly, suppressing noise, masking their scent, and approaching from downwind. The act of hunting demanded patience, hours of motionless waiting, calculated movement, the discipline to delay action until the right moment. These are cognitive tasks, requiring memory, timing, and self-control, not instinct, strategy. This is when the human brain began to specialize in something new, tactical anticipation. Hunting success depended on predicting the behavior of another species, understanding how a herd reacts to fear, recognizing when an animal is injured, isolated, or vulnerable. The brain's neural circuits adapted to process this complexity. Frontal lobe activity increased, especially in regions related to planning, sequencing, and inhibition. Hunting also drove social organization. One human alone had limited chances, but a group with coordination had options. There is archaeological evidence from Schöningen, Germany, dating back over 300,000 years, of spears left behind in what appears to be a strategic ambush site. The location suggests humans planned an attack on a group of horses near a waterhole. This type of coordinated hunting required role differentiation. One group would drive the prey forward. Another would intercept from the sides. A third would deliver the final blow. Each person had a task. Success relied on timing and communication, even if that communication was nonverbal. Eye contact, gestures, simple vocal cues. These were early precursors to complex language. Group hunting selected for individuals who could think collectively, not just individually. It rewarded those who could anticipate the actions of both their prey and their peers. As hunting evolved, so did territorial control. Successful groups began to dominate key hunting grounds, river crossings, migration paths, salt licks. Control of land became tied to survival, and survival became tied to information. Who knew where the animals went, when they moved, and what trails they followed? Knowledge became power, and those who held knowledge began to hold influence within the group. Cognitive archaeologists refer to this period as a turning point, when humans moved beyond immediate survival to planned acquisition. Food was no longer a matter of luck or luckless scavenging. It became an outcome of prediction, execution, and collaboration. This shift also marked the beginning of symbolic group identity. Shared action created shared memory. Successes in the hunt forged bonds. Repetition of roles led to specialization. Over time, groups likely began to develop rituals before and after the hunt, reaffirming their cooperation and perhaps even giving meaning to dangerous endeavors. The hunted had become hunters, but not just any hunters. They were thinking hunters, shaped by memory, strategy, and cooperation. Biologically, this transition left marks on the human species. Shoulder joints and arm proportions adapted for thrusting tools. Eyes evolved to judge distance better. Hands refined for precision grip, necessary for crafting and holding spears. The nervous system calibrated to sustain focus over long periods. And most critically, the brain began to process collective intention. From this point forward, human survival was tied not just to instinct or strength, but to shared strategy. Unlike solitary predators like tigers or even pack animals like wolves, humans did not inherit a fixed method of hunting. They invented new ones. In forests, they flushed animals into traps. In open plains, they coordinated long pursuits. In snow, they studied prints. In swamps, they used poles and fire. This behavioral flexibility was unique. It meant that humans could respond not just to one environment, but to many. And as Ice Age climates shifted, this flexibility became the ultimate evolutionary weapon. The transformation was complete. From prey reacting to fear, to predators planning the future. Part 5. Weapons and the evolution of predatory thinking. The emergence of advanced hunting tools marked a turning point in human evolution. It was not just a technological shift, it was a shift in cognition. Early weapons were extensions of the hand, sharpened sticks, stone flakes, and handheld axes. These required close contact with prey, exposing the hunter to significant risk. But over time, Homo sapiens developed tools that allowed distance, precision, and efficiency. The invention of sharpened spear tips, made from carefully flaked stone and hafted onto wooden shafts, dramatically increased lethality. A sharpened tip focused energy onto a small point, capable of penetrating thick hides and delivering critical wounds. Next came projectile weapons. The spear thrower, atlatl, extended the arm's leverage, enabling a hunter to launch a spear at greater speed and distance. Bows and arrows allowed silent, high-velocity strikes from even farther away. Slings provided rapid, repeatable impact with stones at speeds that could fracture bone. Traps and pitfall systems used terrain and bait to immobilize prey without direct confrontation. These tools extended human reach, but more importantly, they extended human thinking. Each weapon demanded planning, selection of materials, shaping and assembling parts, maintenance and replacement, strategic deployment in the right environmental context. Composite technology emerged. Tools with multiple parts, such as a stone point attached to a wooden shaft with plant fibers or resin. This required not only dexterity, but also foresight and understanding of cause and effect. By 70,000 years ago, Homo sapiens were producing a wide range of task-specific tools. Some were designed for piercing, others for cutting, scraping, or throwing. Toolkits diversified depending on climate, prey type, and terrain. Humans also began manipulating the environment itself as part of the hunt. Using fire deliberately, they could set dry brush alight to create panic in herds. By burning sections of forest or grassland, they forced animals into specific zones, toward cliffs, traps, or narrow valleys where ambush was easier. Fire was no longer just for warmth and protection. It became an offensive tool. But the greatest innovation was not physical. It was cognitive modeling, the ability to simulate what another animal might do before it acted. Homo sapiens began to think like predators, predicting escape routes, identifying patterns in herd behavior, timing attacks based on wind, light, and topography. The shift was from reaction to prediction, from relying on speed or strength to relying on mental rehearsal. This demanded the integration of memory, imagination, and group communication. In effect, humans developed a predator's mindset, not bound to instinct, but informed by knowledge and flexible planning. This mode of thinking spilled into other domains. In intergroup conflict, the same principles applied. Anticipate the opponent's move, strike from unexpected directions, use terrain and timing to your advantage. In negotiation and social exchange, understanding the other side's behavior became a survival advantage. Cognitive empathy, once a hunting skill, became a social strategy. Weaponry also had social consequences. Those who mastered tool-making gained influence. The individual who could craft the sharpest points or most accurate projectiles became indispensable. Knowledge turned into status. Communities began to divide roles: hunters, toolmakers, firekeepers, scouts. Specialization reinforced cooperation, and cooperation became the default human strategy. This is what made humans unique. Not the biggest muscles, not the sharpest teeth, but the ability to coordinate abstract thinking and tool use at scale. Weapons did more than kill. They reorganized the human mind. They required memory, prediction, intention, and instruction. They trained the brain to understand systems, processes, and long-term outcomes. They taught humans to think before acting. This mode of thought shaped human culture, economy, warfare, and belief systems for the next 300,000 years, and still does. In the Ice Age, predators relied on speed, ambush, or brute force. Humans relied on strategy, and that made them the most dangerous hunters of all. Part 6. The Legacy of the Hunted. The human nervous system still carries the imprint of a past spent as prey. Thousands of generations lived under constant threat. As a result, many instinctual responses that once helped our ancestors survive continue to shape modern behavior, regardless of environment, culture, or technology. Fear of darkness remains widespread. In the ancestral world, darkness concealed predators. Nighttime was when large carnivores hunted. The absence of light once meant heightened vulnerability. Today, artificial lighting has reduced the danger, but not the response. The discomfort many feel in unlit environments is not irrational. It is neurological. The startle reflex is another legacy. A sudden noise, a flash of movement in peripheral vision, or a shift in sound patterns instantly triggers alertness. This is not learned behavior. It is a deeply embedded survival response, rooted in the brainstem and refined it through the amygdala. It once allowed our ancestors to react in milliseconds to the approach of a predator. Many humans still report nightmares involving pursuit or entrapment. These dreams reflect ancient scenarios, being hunted, cornered, or chased. They are not merely psychological projections. They are reenactments of patterns once lived and encoded through experience. In this context, nightmares may serve as simulations, training exercises produced by the brain to maintain readiness. The fight-or-flight response, a core element of our survival toolkit, remains active in modern physiology. It is triggered not only by actual threats, but also by perceived or anticipated danger. Adrenaline surges, breathing quickens, blood is redirected to muscles, eyes dilate. These responses were once life-saving. Today, they can be disproportionate, but they are the same mechanisms that kept humans alive for hundreds of thousands of years. This inherited hypervigilance is not limited to biology. It has influenced culture. Ancient fears were encoded into oral traditions and stories. Myths of man-eating beasts, monsters, and supernatural predators are nearly universal across human societies. They are symbolic representations of once real dangers: lions in the grass, snakes in the dark, wolves on the trail. These stories served a dual function. They preserved memory of threats for future generations. They reinforced group cohesion through shared cautionary narratives. The campfire, central to so many early human communities. became a symbol of safety. Fire kept predators at bay. Its circle of light marked the boundary between danger and protection. The simple act of gathering around fire at night, still practiced today, traces back to a time when light meant survival. Even modern social systems reflect evolutionary roots. The preference for groups, the discomfort with isolation, the instinct to scan new environments, all trace back to the prey mindset. But the most profound legacy is this: survival shaped intelligence. Humans did not become smart in spite of being hunted. They became smart because they were hunted. The need to detect, remember, and avoid threats forced the brain to develop complex memory systems, risk assessment skills, and decision-making abilities. These cognitive tools later evolved into abstract reasoning, language, planning, and cooperation. The hunted became strategic. The strategic became dominant. In this way, the prey became the predator, not through strength, but through adaptation. Today, humans are at the top of the food chain, but the instincts of the hunted remain just beneath the surface. In every startled reaction, every cautious step, every fearful story passed down across generations, the ancient memory of being prey still echoes. This legacy is not a weakness. It is the foundation of human survival and human power.